Dear students, today in this session I am going to explain the topic solar constant and temperature of the sun from solar constant. Let us see the solar constant. Dear students, the sun is the source of heat radiations and it emits heat radiations in all directions. The sun is the source of heat radiations and it emits heat radiations in all directions. The earth receives only a fraction of the energy emitted by the sun. The earth receives only the fraction of the energy emitted by the sun. The atmosphere also absorbs a part of heat radiations and air, clouds, dust particles, etc. in the atmosphere scatter the heat and light radiation falling on them. From the quantity of heat radiations received by the earth, it is possible to estimate the temperature of the sun. Therefore, to determine the value of constant called solar constant, certain ideal conditions are taken into considerations. Here the solar constant is defined as the rate at which solar radiation is received by unit area of a black body at right angles to the solar radiation placed at the mean distance of the sun under ideal conditions is called solar constant, which is abbreviated as the symbol S. I repeat, it is also defined like this. It is the amount of heat energy or radiations absorbed per minute by the square centimeter of perfectly black body surface placed at a mean distance of the earth from the sun in the absence of the atmosphere, the surface being held perpendicular to the sun's rays. Here the instrument used to measure the solar constant are called periometers. The heat energy absorbed by a known area in a fixed time is found with the help of the periometer. To estimate the effects of absorption by the atmosphere, The value of the solar constant is found at various altitudes of the sun on the same day under similar sky conditions. If S with the observed solar constant and S naught with a true solar constant and Z with the altitude or angular elevation of the sun, then the formula is given by like this. Here S is the observed solar constant, which is equal to S naught, that is true solar constant, into a to the power secant Z, where Z is the angular elevation or altitude, where A is the constant. Now taking log on both sides, we get log S equals log S naught plus secant Z into log A. Here A is constant. The value of solar constant is found to be 1350 watt per meter square. A graph is plotted between log S along the y-axis and secant Z along the x-axis. The graph is a straight line. Produce the graph to meet the y-axis. The intercept on the y-axis gives log S naught. From the value of log S naught, the value of S naught, the solar constant, can be calculated. The value obtained varies between 1.90 and 2.60 calories per square centimeter per minute. This is about solar constant. I think it is sufficient regarding solar constant. One thing should know all of you about the solar constant is the sun is the sun is the source of heat radiations and it emits heat energy, heat radiations in all directions. The earth receives only a fraction of the energy emitted by the sun. The atmosphere also absorbs a part of the heat radiations, and air, clouds, dust particles, etc. in the atmosphere scatters the heat and light radiations falling on them. From the quantity of heat radiations received by the earth, it is possible to estimate the temperature of the sun. Therefore, to determine the value of a constant called solar constant, certain ideal conditions are taken into considerations. This is about solar constants. I think it is enough for solar constant. Now we switch over to surface temperature of the sun. The sun consists of a central hot portion surrounded by the photosphere. The central portion has a temperature of the order of 10 to the power 7 Kelvin. The photosphere has a temperature of about 6000 degree Kelvin. This temperature is also called the effective temperature of the sun. Considering the sun as a perfect black body radiator, the temperature of the sun can be calculated. Let r be the radius of the sun, small letter r be the radius of the sun, and T be the surface temperature of the sun. According to Stephen's law, the total energy emitted per second by the sun is given by E equals 4 pi r square into sigma into T to the power 4. We know that Stephen's formula E proportional to T raised to 4. Particularly for sun is assumed as perfect black body radiator. Then r is the radius of the sun. Then it becomes E equals 4 pi r square sigma into T raised to 4. Where sigma is the Stephen's constant and small r is the radius of the sun. Now, if capital letter R is the mean distance of the sun from the earth, the energy spreads over the surface area will be 4 pi r square. 4 pi r square. Therefore, according to the definition of solar constant, this is defined as the ratio of total heat radiated per second from the black body to the area of the sphere of radius equal to mean distance. Therefore, you can substitute the value of total heat radiated is 4 pi r square sigma T raised to 4. This is the total heat radiated per second from a perfectly black body. This is according to Stephen's formula, divided by area of the sphere of radius will be 4 pi r square. That is mean distance. Radius equal to mean distance is 4 pi r square. Here 4 pi get cancelled. On rearranging to get a value of the surface temperature of the sun will be T to the power 4 is equal to S divided by sigma into R divided by small r whole square. The effective temperature of the sun is capital T equals, when T to the power 4 is there, when 4 shifted to RHS side, then it becomes T equals S divided by sigma into capital R by small r whole square into whole to the power 1 by 4 Kelvin. This is the effective temperature of the sun formula. By knowing the value of capital R, the mean distance R will be nearly 148.48 into 10 to the power of plus 7 kilometer, and radius of the earth will be in 6.928 into 10 raised to plus 5 kilometer, and sigma, Stephen's constant value 5.75 and 10 raised to minus 5. You can substitute all these values, and S value is nearly 1.94. You can substitute all these things in this formula, and after calculation we got nearly 5730 degree Kelvin. That is the effective temperature of the sun. This temperature, that is 5730 Kelvin, gives the effective temperature of the sun acting as a black body radiator. The actual temperature of the sun is higher than this value. The actual temperature of the sun is higher than this value. The temperature of the sun is usually taken as 6000 Kelvin. Temperature of the sun can be calculated from Wien's displacement law also. The Wien's displacement law is lambda T equals a constant. The constant value is 0.2892 and the lambda value will be the wavelength of the radiation for which the energy is maximum in the spectrum is 4900 into 10 to the power of minus 10 meter, that is lambda m. You can substitute all the values. By substituting the values of lambda m, the value of T comes out to be nearly 5902 Kelvin. This value is in agreement with the accepted value, and the effective temperature of the sun, that means photosphere, is about 6000 Kelvin. This is about surface temperature of the sun. Thank you.